Hello everyone. In this video, I will be explaining you about the Chapter 9 case problem which is related to Grey Code Corporation. Grey Code Corporation performs data mining activity and collects information related to different types of, I'm sorry, different details related to the people and their ability to renew the program. Okay, there are multiple attributes that were included on the data given. So the data consists of several attributes and the description related to the data is given in this column. Okay, when I send you this one, you just have a look on it. So based on these attributes, we are supposed to identify whether the customer who is having a TV um, subscription, whether they will be renewing it or not. Based on these data, the collected data, we are supposed to conclude. So what it was asked is, we are supposed to use different types of classification methods in data analytics, and we are supposed to compare them, and we should make a proper recommendation to the organization. So before we apply classification, it is crucial that we apply data cleaning activities and identify appropriate attributes that helps us to perform analysis. See, every time I'm addressing the answer, I will tell you which screenshot from the Excel sheet should be used in your Word document and which is not. And from when we are using values, what values are supposed to be mentioned and how they are supposed to be interpreted in the document, I will be explaining it. Make sure that you give a nice introduction to the case study, then start exploring each and every section. Okay. So please follow my video and listen completely so that you can give better response and better manager report is developed by you. All right. Let me start explanation. After giving introduction to the given case, we start explaining the process of exploring data. So usually, like while we performing data analysis, we use certain steps, right? So in that we speak about data cleaning and filtering data and selecting appropriate attributes that can be used for further analysis. Okay, so these steps will be given in a one paragraph, and the attributes that we have selected is mentioned in selection of attributes based on the correlation analysis. These are the weights that are allocated in sequence. So you can mention any five from the list and mention other attributes. For example, if I want to write, I say dollar per use, total paid orders, household size, child present are some of the important attributes that are considered. Along with them, there are many other attributes. In that way, I might be mentioning. So make sure that you also write in the same manner. Some XYZ attributes are selected by you while performing the activity. When we write this, after giving a nice explanation about what kind of work we have contributed to make sure that data is properly cleaned. Okay. Now, the second one is after performing classification, we are supposed to test the data. Okay. So this is all related to the experimentation. So need not to write anything related to second question. So now, after mentioning what kind of attributes are selected, we start explaining comparative analysis. So we are supposed to perform comparative analysis on classification methods. So let me show you the comparative methods that I have used. See, classification methods that I have used are naive based method, generalized linear model, logistic regression, deep learning, and decision trees. These are the five different models that I have used in the process of analyzing data. So among these five, select any two or three models. Okay, I recommend you to select any two models to conduct an performance analysis. Okay, make sure that you select any two, just two models. Don't go for third model. It is okay even if you use two models. Okay, so any among these five models, you can select any two models. That's okay. So the next step is it was asked to compare the models by using the results it generates. So it is mentioned here that we are supposed to give ROC curves, lift charts, and other extra things, etc. things. So usually when we perform classification analysis, we get a detail such as ROC curve, lift chart, performance, and confusion matrix. These are the four important elements for any classification model we get. Even if you cross check the other tab, it consists of important factors: ROC, lift chart, performance, and confusion matrix. These are the main elements that should be included in your document while comparing two elements. So let us start with the first model. Whatever the model that you have selected, mention model 1. You have to give model name. If it is naive base, you should give naive model 1, naive base, or naive base. Okay, so model 1. For that, you are supposed to give first one, you explain, you give a small introduction mentioning you are not supposed to use any screenshot. You just mention the names of the important factors that are used that highly influenced this model. So these are the top 6 or 7. You take five more, any five elements from this, and mention that these five attributes influenced the model very much. Okay. So after that, after giving an introduction to important factors, start with ROC curve. So copy paste ROC curve, and we are supposed to interpret the ROC curve. What ROC curve explains is usually like when we take the same curve. Let me tell you how to interpret this. See, when we are interpreting ROC curve, if you take 45 degrees, see, this is 90 degrees, right? 90 degrees graph. Okay. In this, you take 45 degrees curve. So when you take 45 degrees curve, and if your ROC curve is more than that, it means that the possibility of generating accurate value is high. So, like when the curve is more far away from 45 degrees curve, means from this line, if the curve is far away, it shares, and if it is near to the one means like this edge. When if it is near to this edge, it means that like as near to this edge. If for example, if the curve is like this curve is like this. So this means that the model that is generating this curve is far better than the model that is generating this curve. Okay, because to what extent it is near to 1.0, that makes it more accurate and more perfect model, which has the ability to predict perfect value. Like when you go some sample independent variable data, it can generate more perfect result for predictions. All right. So based on the graph, so we see that for naive Bayes graph, it is above the 45-degree line, and it is very near to one value. So the possibility of generating true positives, true positives and true negatives will be high. So this curve is giving a positive indication that the applied model has more ability to generate accurate value. So when you are interpreting for other model also, the same interpretation, you just cross check how the curve is, and based on that you just explain uh, your interpretation. After ROC, we will be using lift chart. It's a very simple one. Again, see this, whatever the population we have, that we divide into total 10 different what we call classifications, understand. Okay, so when we take first 10% of data, what is the accuracy it is generating? So when we take first 10% of data, we are getting 63% of accuracy. So this is how we interpret it. When we add next 20% of data, the accuracy increases to 77%. So when we take another 30% of population, means when we take first 30% of population to test the analysis, the accuracy is 84%. So similarly, when we take complete 100% of data, the accuracy will be 100%. For example, in the third question, it was asked like when top 10% of data is collected, which model is better performing. You can see that Here, when 10% is selected, the total accuracy it is generating is 63%. Okay, so this one is having better value maybe. So based on that, you can say when we take only top 10% of data, which model can be performing high. So because when we use more data, the time taking for evaluation purpose and to interpret data, it takes a lot of time. So when we take smaller classification and if we try to analyze also, the data should provide better results. However, 63% of accuracy cannot be accepted. At least we need 90-95% of accuracy. Here, at 80% of data, we can see that 96% of accuracy is identified. So for when we are applying generalized linear model, 80% of data is enough to interpret and make assumptions about trends. Okay, so this is how we interpret it. After this, let us take performance of the model. So performance of model, we don't copy paste anything like for live chat, live chat, we take this chat and copy paste it. So and you can modify it by adding colors. You can change the color of graph and apply it rather than using straight away whatever the graph that is given. So better you change color of the graph and size of the graph. Okay. So now in the performance, we don't use any picture. We just try to take values from the performance. Okay. Performance results. So from the performance, we see that we have three main details here: accuracy, classification error, and AUC. AUC means area under curve. We have ROC curve, right? In this ROC curve, to what extent the area is distributed, that we will be evaluating. Okay, so accuracy should be always more than 95%. So simply saying, when we are comparing accuracy of one model with other, so whichever the model is having higher accuracy, that will be considered as better performing model. All right, so accuracy speaks about the ability of predicting accurately. For example, if you say that from the classification, the result will be yes, the customer will be subscribing to the data, subscribing to the TV channel, or he might be subscribing. If you say that we say if we say that the customer will be subscribing, 97.7% chances are there to get subscribed. Only 2.3%, that is classification error. When we subtract this from 100%, we get 2.3%. Only 2.3% of chances are there that our prediction go wrong. And AUC curve means like when this classification, to what extent the curve is covered, the area of curve will be covered. So when the value, based on the value, we can say whether the area under curve is good or bad. So we say when the value is 0.921, means 90% to 100%, we say that that is best value for AUC. And the when value is 0.8 to 0.9, means 80% to 90%. This value is between 80% and 90%. So it is a good value. It is a good value to select your model. If the value is 0.7 to 0.8, which means that 70% to 80%, if AUC value is 70% to 80%, then we say it is a fair model. Okay, not best, not good, but a fair model. If the value is less than 0.7 and greater than 0.6, means if it is 60% above but less than 70%, then we say it is a poor model. Something less than 0.6, it means 60%, we call it a failed model. That model cannot be applied. All right. So these are three important things. Based on that, you can explain. So when you say that if the model has 97.7%, 97.7% is a higher accuracy. So we say that the model has ability to generate higher accurate predictions. So simply we can say that. And for classification error, if the classification error should be very low. So when the accuracy is high, obviously the classification error will be low. Classification error speaks about the percentage of chances at which whatever we predicted might go wrong. Okay, so that we discuss. And area under cover, AUC speaks about to what extent the possibility of the selected classification comes under the curve, that is 84.9. which is a good value. Okay, so please re-listen this one and try to understand it. It's very interesting facts that you can write about the given model. Okay, so after that we discuss about confusion matrix. So so it is very important to mention performance. If even if you don't write about confusion matrix, that is fine. Okay, better you include it. That's my recommendation. Okay, so confusion matrix speaks about false positives and true positives. Okay, so for example, if we take the prediction as no, what is the possibility that the estimated value will also be no? That is this one. So when we have nearly, like when we sum these two things, it will be 11,752, 62. 11,762 samples were collected. Among that, when we say, when our prediction is no, the output is also no, like the actual real value is also, prediction and real value different, right? We might predict that tomorrow it will be raining, so the possibility of raining will depend on tomorrow, right? If it rains, then when we say it rains, it rained, and when we say it doesn't rain, then it never rained. So based on that we calculate what is the accuracy value. Okay, so class precision will be taken, whatever the least, um, among the highest values that will be selected. So here you say check, when the prediction was no, he won't subscribe. The chances of predicting not subscribing is very high. That is 11,729. The chances that even we predict that they won't purchase the subscription, 242 people purchased it. This is classification error. Okay. Now class precision says the accuracy high. What is the accuracy that when the prediction is no, it happened? That is 97.98%. When the prediction was yes, they subscribe, how many people didn't subscribe? 33 people didn't subscribe. So when prediction was yes, they subscribe, 33 people didn't subscribe, and 18 people subscribed. So here the when the value is subscribing truth, the possibility of getting the actual value is very low. It is 35.29% accuracy in that context. Overall, when we take the thing like when we take values, what it says, 97.7% is the accuracy, and 2.3% is error, classification error. So these values should be interpreted, and based on the see, just write same thing for next model also. Okay, you select any other model and try to write about it. Same sections will be written for other option also. Okay, for model 2 also. After completing model 2, we will be giving a comparison. Okay, which is best one. In that area you check for accuracy, you check for AUC, and you check for classification error. You try to compare both the values. For example, for first model it is 97.3%, and for second one it is, if it is 97.8, you say that the model with 97.8% is better option. You should also speak about AUC and how it is distributed, whether the model is giving better value or not. When compared to all three things, so this and this go hand in hand, but when compared to AUC and accuracy, so whatever the model got the best value, that you should explain. And the final question is here. By this, it got completed. And the last question is related to this one. So when we take top 10%, so you just cross check this chart, lift chart, select for 10% for this. If we are comparing these two things, so for naive base, it is when first 10% was selected, it is 33% of accuracy we received. And for this one, when we selected top 10%, 63%. So when we compare naive Bayes with generalized linear model is having better performance. So simply we say that so this scenario, generalized linear model is best for the industry. That we write here. So and then we write a recommendation based on your comparisons. You just make a recommendation to the company when they use which model, it will be helpful for them. And there should be a conclusion which covers all important elements related to the case study analysis that we have performed. So introduction, recommendation, and conclusion and reference should be included in your document. Last time I saw that most of you people have forgot to include references. Please make sure that you include reference of any data science book. Okay. So that is all about chapter 9, case problem. Please help yourself and complete the activity. Thank you, team. And it is hardly 500 words work.